It probably took me a month just to sit there and think about it and do some calculations and stuff to figure the volumes and stuff. But just basically pictured what it would be like to work it, and then incorporate the principles into it, and then just basically pick my set points and start building. There were several different products I thought about using: concrete, plastic, everything, and I ended up using stainless steel. At that particular time, on volume, stainless steel was price competitive, and I have no regrets on that, because stainless steel is one of the easiest products to take care of on a tank. We've yet to clean any of these tanks out, because the fish do it themselves. Stainless is just non-porous, and like concrete, any kind of pores you got, bacteria, organic matter, anything will set in a pore or a crack or a filter and just fill up. You got to blast it out, because that's just a place for bacteria to build. So I just settled on stainless.
There's a real tendency to over-engineer, and I see that probably more than anything. And my father's an engineer, and I consider myself a junior engineer, growing up in an engineer household. You know, every construction toy that ever was made. But I enjoy building things, but the key is to keep it as simple as possible, and I think that's probably the biggest key. I just read an article yesterday about this really high-tech thing that I won't name them. It's an institute that was doing research, just bells and whistles and just high-tech. Well, and then they talked down a couple pages later where they had catastrophic loss of everything because some wire melted on something and the whole thing crashed. You know, it's just when you have a lot of high-tech components, you just increase the number of opportunities for failure. Our biggest things that we have to be careful of are power outages. You know, we have alarm systems, we have phone dialers. You know, we've learned some of these things the hard way when we first started out. Backup generators, you know, things like that. So it's no big deal. So it's you have to plan for those details, and it's the details that make the difference between a one that's going to work and one that's not. And I think it's always going to be that way. But you have fewer details if you have a simpler system, and that's so important.
We started in this building. We've got the large tanks here. When the perch come in here, 1.5 to 2 inches, you can put 100,000 fish in one tank, which sounds very great, sounds efficient, nice way to handle them. The bad thing is you've got 100,000 fish at risk. You know, that could be half of your whole year's production at risk in one tank. So if one thing goes wrong in that tank, you're in trouble. You got a lot hanging out there. Our other building, we've got small 1,000 gallon tanks. We're going to put 15,000 to 20,000 of those small fish in those tanks, then grade them out. First off, you spread your risk out. You got maybe 6 tanks with that same number of fish in. It's a smaller batch that you can grade out easy. When we want to catch all the fish out of this tank, to know I got them all out, we've got to drain the water down. Well, it takes a lot of time and a lot of water to replenish. You know, there's 12,000 gallons we got to dump out to know that we got them all out. In the other barn, the 1,000-gallon tank. It's quick, it's simple. I can do a small batch of fish at a time. I'm not committed to doing the whole tank at one shot. So those tanks complement these real well. Yeah,
it's working. In fact, we just increased the flow in one tank, and feed consumption went up. So I don't know where the maximum flow would be before you'd wear them out. But yeah, I set it up to where I can change a few things to do a little experimenting with it. We've done some experiment with oxygen levels, flow rates, a few various things. We've increased the production with the same amount of fish over the last couple of years, every year just a little bit, just by changing a few things, modification, experimenting. We're still learning.
Yes, we bought one tank as a prototype. We diagrammed it, blueprinted it, and then started construction. So we built for the other 7 tanks. We're now working with the original engineer. We're distributors for the system now in fiberglass. One of the things he liked about the fact was that we had already diagrammed the tank and built them ourselves. We knew the construction process of it, so we knew the tank inside and out, which really was an asset to us. But As far as a learning curve, talk to a lot of people. I guess it a term I use a lot is your risk comfort level. We saw other people do this, we saw how they did it, and we had an idea what we needed to monitor. And we thought, well, the only way we're really going to know how to raise fish is to jump in and do it. Some people spend years and years researching before they ever make a decision and make a move. We decided that we wanted to go into fish. That was a decision. Wanted to start step one in the process. We found a facility that we liked. That was step two. Once we had that, the next goal was to get our building ready and tanks into it, and learn as you go. I mean, you do a lot of reading up front, but until you actually put the fish in the tank, read the oxygen levels, read pH, check your alkalinity, check all these different parameters. You know, it's a bunch of numbers until you actually start doing it.